Hi everyone, thanks for joining today. Really appreciate your time, especially after lunch. So I appreciate that you may be in a slight lunch coma, but hopefully this session will at least be kind of easygoing, easy to listen to, and hopefully informative as well. So today I'm going to be taking a look at how the open source community really breathed new life into Java, sort of how that happened, perhaps tips and tricks that can be taken into other languages and other communities, and also sort of where we see the future of Java going from here as well. So for anyone who's not met me before, hi, my name is Grace Jansen. That's when I had straight hair. You can see it's not like that anymore. So yeah, I work as a developer advocate at IBM in the UK. I work in our lab in Hursley, so it's just south near Southampton, about an hour and a half away, so not too far. I actually did a degree in biology, kind of weirdly, and then went into Java, a natural transition, as I'm sure you'll all agree. So it was a bit of a steep learning curve, definitely a lot to learn, especially because the language is older than I am. So that was interesting and quite intimidating when I first joined. But since then, I've gone on to become a Java champion. So that's a group of people from around the world who are sort of recognized by the Java community as sort of really supporting, encouraging, and sort of being at the forefront of enabling Java in the community. Other stuff that I do, I'm an inventor at IBM, and I'm also passionate about encouraging diversity as well. So that's just a bit about me, but moving on, because we're all here for Java, not for me. So I'm going to start with sort of a bit of a brief intro in case anyone here isn't a Java developer but wants to know a bit more. Then we're going to take a look at sort of the journey that Java's taken into that open source community and then how that's changed the Java landscape and what that means for this sort of community and programming language. So for anyone who's not familiar with Java, this is a super high-level intro to it. So please, we could do a whole course on what is Java, but we're just going to do a high-level intro. Really, it was sort of introduced to enable things like simplicity, platform independence, things like being able to have multi-threading, being able to have a robust platform as well. It's meant to be a general-purpose programming language. It is object-orientated as well, so we do make use of objects. And it was the first programming language, really, to provide this concept of writing programs that are going to be executed on the web. As I said, it was designed to be able to have this platform independence, this portability and flexibility, and that's achieved through the JVM. So essentially, as you can see from the diagram here, you can essentially run the program anywhere that enables that JVM to run. So it means you just write it once and you can run it anywhere instead of having to customize that for each individual environment, which makes it quite portable and flexible. And now it's used in a wide variety of different things. So for web and mobile app development, especially enterprise app development, there's also games engines and IoT. So it's quite a widely used language. It's quite popular. It's robust and utilized not just in sort of, it's utilized in, say, startups and stuff, but also in big enterprises as well, because it's known for its reliability. So as I said, Java has been around for a while. This is like almost a 30-year-old language. It started in 1995 when a team at Sun sort of came up with this concept of Java, led by James Gosling. You've probably come across him if you're in the Java world. And essentially, they, as I said, aimed to develop a language that could be used in various different consumer electronic devices. So really, lots of different stuff was what they were aiming for. And the very first beta release is what came out in 1995. The initial release, which is the first known version of Java, so Java 1.0, came out in 1996. So it is a pretty old language when you think about it. There are much newer languages out there, so for example, like Go, Kotlin, that are quite exciting and new and innovative. And as someone who is younger than Java, as you can see from the diagram, the baby is meant to represent me in this case. It can be an intimidating environment to come into because you're coming into this environment where you're working with people who have been working with Java since it was first released, literally more than you've been alive. And you're thinking, how on earth am I ever going to catch up with everything that I need to know to be able to actually effectively develop in Java? At least that's the thought that I had when I entered this world. And so it's also a question of, okay, if this language is over 30 years old, how is it still relevant to applications that are being developed nowadays? Because when this language was first developed, the cloud wasn't really a thing. We weren't developing for microservices. You know, we had generally monolithic applications. So how is it that this language is still relevant to me as a new developer coming into the world of enterprise and the world of sort of companies looking at developing applications? We had this sort of boom, sort of the late 1990s, early 2000s, when cloud started really becoming a thing, started becoming something that we could adopt and something that we were striving towards. So, the earliest mention of cloud computing was in 1996, but really, the beginnings of the cloud platforms that we might utilize nowadays happened around 1999. We had Salesforce becoming popular. We had 2002, Amazon launched AWS. We had things like NASA starting to launch open source initiatives in this space as well. Things like OpenNebula, trying to really standardize the stack that we're making use of when trying to develop in the cloud, which then turned into OpenStack. So we're starting to see open source coming to the forefront. We're starting to see cloud-native technologies and cloud platforms starting to emerge, and really this excitement among developers of moving towards a cloud-native ecosystem. I haven't included it in these slides because I feel like I overuse it, but if anyone's seen Toy Story, you know that scene when the aliens see the claw? I always feel like that's what we're like as developers, the cloud. We get really excited about it because it's a cool, innovative platform and we can gain a lot of advantages from it. But where does Java fit in this? And that's kind of where we start to journey after this sort of interest or rise in popularity and interest of the cloud and these cloud-native concepts. We start to realize that actually open source seems to be a very strong, there's an emphasis on it as we start to go towards app development. So in 2006, this is where Java's open source journey really started to take off. So in 2006, Sun officially open sourced the Java JDK, and it became OpenJDK. So that's Java Development Kit. I feel like in software, we speak Latin half the time because we've got like a million acronyms. So if I don't say any of them, please just let me know and I will define it if I forget to. But essentially here, they released within this the majority of Java's source code under an open source license. Now, when I say Java's source code, this was what we call Java Standard Edition. So this is really the standard version of Java, and it was aimed to be able to help improve the code and deliver more enhancements. There is only so much you can do as one single company when it comes to being able to have the resources, the time, and the money to invest in all of the new improvements and enhancements that you want, especially in a programming language. So by open sourcing this, we're able to start journeying into this cross-collaboration, this innovation through open source by collaborating with other individuals and companies. And this is kind of where Java started to turn. Java was super popular, but there came to a point where in that sort of 2006 era, we started to realize that actually there are a bunch of additional enhancements, improvements, and capabilities that we'd need if we wanted to be able to develop effectively with Java for cloud-native applications. And so we started to realize that actually through open source standards and open source projects and initiatives, this is where we could achieve that through collaboration. So as I mentioned, in 2006, Sun open sourced the standard edition of Java, and it became OpenJDK. It was really just a free open source implementation of the Java platform, and it is still the basis or the base code upon which all other distributions of Java are built. So it is still utilized today by lots of these other open source and proprietary Java offerings. So you might be familiar with Adopt OpenJDK. OpenJ9 is the IBM Java that was open sourced, and there's also Oracle as well. There's lots of other Javas that are available now, Corretto from Amazon, for example, depending on which flavor you're interested in and what add-ons you want to make use of. But it was a really good first step forward. But I say first, because it is not everything we need in the JDK. Java Standard Edition is fantastic if you're just making use of the core features in Java, but what Oracle also offered at the time was Java Enterprise Edition. This is an additional set of, it's basically an extension to Java Standard Edition, which is really built for enterprise applications, and this was still missing from the open source community. So in 2016, so we've jumped a bit here from 2006 to 2016, at this point, the cloud is pretty much an expectation rather than something that could appear in the future. At this point, the developer community is really starting to think, okay, Java's not progressing at the pace that we need to be able to have the functionality and features we need for cloud-native applications. We're missing things like being able to have externalized configuration from our code, health, metrics, being able to have sort of like RESTful without going into the Java enterprise, RESTful communication. And so at this point, the community decides to get together and come up with an open source project that builds on top of Java EE. So basically, because it was kind of, I guess, bypassing Oracle in terms of instead of having to wait for Oracle to actually develop that and bring it into Java EE, we were able to basically say, right, we're just going to add this on top of Java EE, and that allows us to have much faster innovation at a much quicker speed. It's not, I don't want to put a downer on Oracle because they were doing a great job of stewarding the Java language, but as I said before, there's only so much you can do as one company when it comes to enabling that innovation within projects. And so at this point, microprofile was introduced. This is really a community-driven specification that's designed to be able to add on these key APIs and behaviors that we want in cloud-native applications. Now, this is microprofile 6.1. This came out last year. It's the most recent release of microprofile. So not all of this was in the first release. Obviously, stuff's been added as we've realized the importance of it, and we've been able to develop it further. But this is the most up-to-date version of what you can get with microprofile. And as I said, it includes lots of key elements like being able to inspect the health of our microservices, being able to gain key metrics to understand that behavior over time, especially when we're creating distributed applications in the cloud. Also things like having that external configuration, being able to utilize things like the Open API initiative as well. So drawing in from other standards and other communities as well into the Java ecosystem. So really allowing us to utilize this wide variety of behaviors. And the nice thing about microprofile is that, as I said, it really is a community-driven initiative. So this is developed by a huge range of individuals, but also companies who are interested and invested in really making that open source standard and allowing there to be portability and flexibility between different products and different runtimes. So as I said, lots of companies are also invested in this. This is some of the ones on the microprofile website that you'll find that actually directly help to develop microprofile as that sort of open source standard. So in 2017, this sort of introduction of microprofile really spurred on the need for greater collaboration and innovation through open source. And so what happened is Oracle decided to donate the Java EE spec to the Eclipse Foundation to become Jakarta EE. So at this point, we've already open sourced Java Standard Edition. We've got the Open JDK. We've also got microprofile building on top of the Java EE ecosystem. And now we've open sourced the Java EE ecosystem. So now enterprises can really make use of and contribute to where Java is going to go in the future and how it's sort of enabled in that cloud-native environment. So this was a big step forward. And what it allows us to be able to do is, as I said, help to not only contribute to that specification and enable more feature enhancements and innovations within the language, but it also helped us to be able to steward and direct and shape the future strategy of where Java is going. Instead of it being sort of locked into one particular vendor's strategic pathway, we were able to make it a lot more collaborative and sort of for the whole community in that regard. You know, vendor lock-in and was mentioned in the keynotes earlier quite a bit about the fact that, you know, vendor lock-in can result in products or languages or initiatives that don't suit everyone, and it can also become an issue when it comes to if you want to switch from that particular one, for example. That flexibility and portability just isn't there. And so this is where introducing Jakarta EE was really critical in turning around Java to be community-led and ready for the cloud. So as I said, it's in the Eclipse Foundation, which is the same foundation as microprofile. So the nice thing about these being in the same foundation is that they can be enabled, the same people can essentially work on them and help to bring them closer together so that those microprofile specs and Jakarta EE specs can hopefully sort of merge and become one. In fact, anyone keen-eyed will have spotted actually a lot of the Jakarta EE specifications are already included as part of that microprofile stack already. So there's loads of close collaboration between the two, which is fantastic for actually enabling those behaviors that we need. There's also a huge community of companies and individuals contributing directly to Jakarta EE, shaping that. They've become members of the board, helping to shape that strategy and drive that innovation forwards so that Java doesn't remain sort of mediocre and just sort of a language that once was, but actually remains relevant and a language of choice for enterprise applications as we enter the cloud-native ecosystem or the cloud-native world. Now, what all of these innovations and this move towards open source also drove was this shift in runtimes, or as they were once called, sort of app servers. So when I talk about runtimes here, what I really mean is the next evolution from app servers. So you might be familiar with things like WebSphere, JBoss, things like this. They were generally proprietary offerings that were offered by individual companies, built for sort of applications that were maybe a bit older, not necessarily built for the cloud. But now we have this whole spectrum of runtimes that offer the same sort of capabilities and features, this sort of app server functionality, but for the cloud, ready for the cloud. And the nice thing is that this move towards open source, this move towards collaboration, has meant that they now offer many of these as open source projects that you can just pick up and make use of and try out yourself. And what this does mean is that it enables cross-compatibility, that more of that flexibility and portability. So many of these open source runtimes actually support and make use of microprofile and Jakarta EE. So it means you just have to write the code using those standards, and if you want to switch from, say, Quarkus to OpenLiberty or OpenLiberty to Pyara or whatever you want to switch to, it's much, much easier because you're not re-architecturing your whole application. It's coming back to these key principles of, this feeling we get, ooh, the cloud, think back to Toy Story. This feeling we get of, why are we choosing the cloud? Why are we putting ourselves through the pain and the frustration that sometimes comes with cloud-native development? And the reason we put ourselves through it is for those behaviors and innovation that we gain. Portability, flexibility, reliability, innovation, you could say fashion, because when you think about the cloud, it really is a fashionable thing to do. People like to be able to move to what's fashionable, what's cool, what's trendy, and that gets us excited. And so it's these key behaviors that we're seeing sort of enabled through this open sourcing, things like portability and flexibility that are why we're moving to the cloud. And then actually, a key thing here that I wanted to pull out from this, the reason that this is important was actually brought up in the keynote as well, because this introduces competition in a healthy way. Because if you're all utilizing the same open source standards and you're all collaborating on this innovation in terms of microprofile and Jakarta EE and all of these things, then you have to do better yourselves in terms of the product that you're offering. You can't just base yourself on the open source and expect people to use you. And what that means is that through this healthy competition, we're able to see further innovation, further improvements to Java and to Java applications. I love this quote by Nancy Pearcey where she talks about competition is always a good thing. It forces us to do our best, as it was sort of said this morning in the keynote. And a monopoly renders people complacent and satisfied with mediocrity. I think that's the biggest thing when it comes to languages is if there isn't a strong community behind them, if there isn't sort of development sort of forcing it to be able to sort of take up these innovations and change and modernize and be better, then you are going to fall into this pit of mediocrity and the language will probably die. So languages really have to be kept in sort of competition with other languages, but also have that strong developer community behind them. And I think that's really what the open source movement has allowed for Java. It's breathed new life into Java to allow it to be sort of still the language of choice for enterprise applications moving to the cloud. And as I mentioned, this competition allows us to be able to gain further innovations. So being able to move to the cloud easily through compatibility with things like containerization technologies, whether it's Kubernetes or Docker or Podman. With the recent licensing changes in Docker, you might be looking at alternatives. I'm using Podman now, for example, which is an open source project from Red Hat. Really cool if you haven't checked it out. There's also things like build packs. Build packs allow you to be able to build your application image by utilizing pre-built images. So you don't have to provide a YAML file or anything like that. You just provide the application code, and essentially the build packs do all the work in the background to piece together the different parts of the image that you might need. So some really cool technologies here that are enabling better, more efficient cloud-native development that we're able to integrate our Java applications into. Also things like rapid startup. Something that the Java community has, and I think this is fair to say, always struggled with is the fact that it's not always necessarily most performant on startup times. And that's because of a variety of different reasons, including the fact that we have very efficient garbage collection that takes a bit of time. We're very efficient in terms of resource utilization. Again, all of this leads to sometimes a slower startup time than other applications. But with, again, the competition that we've seen, the collaboration in open source, we've seen a huge decrease in startup times. So we're getting much rapid sort of ability to be able to use our applications, which really suits the cloud, moving more towards sort of that serverless environment while still gaining the benefits of having a server running in the background. So for example, technologies like GraalVM, so having native images, or utilizing projects like Cryu or Crack, which you may or may not have come across, which allows us to be able to take a running checkpoint of our application and start up our application from that checkpoint. So instead of having to start everything again, you just go straight to that running checkpoint, which allows much faster startup times. And these are innovations that are only coming in the last couple of years. So really you can see this competition, this healthy competition, this drive towards open source is really allowing the Java language to continue evolving and developing, and the wider ecosystem as well. Another one, as I said, resource consumption. Java has always been pretty good at resource consumption and being quite efficient, but that's just been improving as we've gone to the cloud. When we previously had Java running on our own systems, say, on-prem, for example, we could just provision more resources. Whereas when we're running in the cloud, it can be pretty expensive if we're whacking up the amount of resources that we need continuously. And often we'll have a specific budget for the cloud that we can't go over. So what we want to be able to do is have the same performance, the same throughput, without having to keep ramping up sort of that horizontal scaling of our resources. And so by utilizing things like JIT server and separating that out from our running server, we can essentially be able to share a running instance of a JIT server so that we can make a much more efficient resource utilization when we're running in the cloud. So again, that's a new thing that's been coming out in the last couple of years. If you're interested in any of these technologies, there are articles that I've linked to in small, because the slides were already quite busy, so I didn't want to distract. They are in small at the top here, and I will share my slides afterwards. So there's a link here to an article we've done on sort of what is a JIT server, and why does it matter if you're separating it out, and how does that improve the performance of your Java applications. There's also a link here to essentially what Crack is and what Cryu is, and how that can help your startup times of your Java applications as well. So hopefully, I know I'm whizzing through these innovations, but the idea was really to show you the evolution that we're taking rather than specifically, because we could spend a whole session on each one here, and we don't have the time for that today. So hopefully you can utilize these as sort of homework if you are interested in any of them going forward. And the list doesn't end here. These are just some of the examples I've picked out. We've now got things like agile hot reload deployment. So this is fantastic if you're interested in agile local development. So really, if you're sort of trying to take on those agile methodologies, being able to rapidly see your code changes or configuration changes as you're making them is really important. You don't want to have to tear down your whole application and restart it and wait for that to sort of start up again to be able to see those changes. So what we can do actually, Quarkus, for example, has something called Hot Reload. In OpenLiberty, which is the project that I work on, one of those runtimes that I mentioned, we have something called dev mode. Which is just short for development mode. But essentially what it allows you to do is the server will listen out for configuration and code changes, and it will update only the classes that you change. So what it means is you're not having to tear down your whole application. The server is automatically able to show you those changes in real time in your local environment. So it makes for super agile, quick development on your local machine, which is really important when we're trying to increase productivity and enable that sort of fast iteration in our applications. Other things as well, reactive, a topic close to my heart. I love reactive because I find it super interesting, and to me, it correlates completely with nature. I did a whole talk on how reactive systems are just like bees. So if you're interested in that, come speak to me and I can send you a link to the presentation. I love making analogies to nature. So I've got quite a few of them, like how security is really just like the body in how we deal with viruses. So feel free to come up afterwards. I'll talk your head off about it. But reactive systems really allowing us to be able to have super quick sort of instances of being able to respond to things quickly in an event-driven manner. So we've got things like reactive messaging through projects like Vertex, another open source project you can check out. And MicroProfile has one called Reactive Messaging. So do check those out if you're interested. And it allows great compatibility with event-driven architecture platforms like Kafka. And other things like platform as a service as well. So moving towards this idea of being able to utilize a platform, an internal developer platform to be able to develop is also somewhere where I think Java is going to go. And this goes wider than just the specific, what are we doing in the Java language? There's a wider ecosystem here where we're innovating and utilizing open source to help improve our wider ecosystem. So things like integrating with other compatible open source projects, so things like test containers. Test containers really allows you to be able to test in an environment as close as possible to production, because when you're deploying to production, you're deploying in containers most of the time if you're utilizing the cloud. So it makes sense that you're testing in those containers as well to make it as close as possible, really relating to those 12-factor app methodologies. Other things like adoption of open source standards. So I mentioned the Eclipse Foundation already, but things like the Cloud Native Computing Foundation, we're utilizing things like OpenTelemetry from there as well. And even AI. So we're starting to look at things like LangChain for J, which really allows us to be able to use language models and AI to be able to utilize those within Java applications. So that's literally just happening now. It's pretty brand new. Quarkus has an integration with it, and we're looking into it in OpenLiberty. But it's pretty exciting because really it shows the future that Java isn't just going to stop innovating here. We're going to keep continuing into this world of AI and wherever the cloud may take us. And this isn't possible without the community. I've mentioned this word several times throughout the presentation. This is because there's a huge amount of support from developers around the world who are passionate about Java and seeing it sort of evolve and continue into this cloud-native language. So there's a bunch of different Java user groups all around the world. You might see some local to you. If you're based in London, as we are here, we've got the London Java community. Or if there's not one local to you, we have the virtual Java user group as well. So you'll always be able to join that. But there is a community all around the world. So this is actually from the dev.java website where it shows you all the jugs from around the world. So you can see that really Java is supported by this huge ecosystem of people from all around the world who are contributing to these open source projects and enabling that innovation to continue. And that's because they enable all of these things: events, education, conferences, unconferences, meetups. There's a huge amount of activity happening within the Java space that allows this to continue. Now, I know I'm almost at time, so I'll be quick. So what does this mean for Java now? Well, it means that Java isn't, it isn't your father's Java, as you might say. Java has evolved, it's changed, it's kept up with the times, and it's got all of this innovation that's happening. So in fact, Java, despite being older than me, is still an extremely popular language to make use of. Java, actually, these are from two different reports. So on the left here, we've got it from JetBrains, second most popular programming language from their survey. And on the right here, we've got it from GitHub, and actually the fourth most popular language. And if we're taking a look at ones that are just sort of, not really necessarily just sort of front end, but really enterprise languages, Java's pretty high up there in terms of ranking and popularity. In fact, there was a survey done, this is from the State of Java report from Azul, where 98% of businesses continue to use Java, and 57% of those organizations say it's the backbone of more than 60% of their applications. So you can see it is still a popular language that is still being utilized in enterprise today to enable effective applications. And it's utilized by a lot of different companies, which you might see here, that are really supporting, encouraging, and contributing to that innovation. And some of your favorite games, for example. So, I promise this is the end. In summary, thanks for sticking with me as I whiz through those. In summary, Java remains a powerhouse of enterprise applications. There is continued innovation in this space, which allows it to be able to stay current and sort of be ready for the future of application development. If you want some more resources, feel free to check out these links after the presentation. And with that, I'm going to say thank you so much. Appreciate your time.
was 15 minutes ago.